Good afternoon, ma'am. My name is Ihsan Andrinal. Having spent over a decade working directly in streamlining government services and enhancing trade facilitation, I have witnessed the operational friction between compliance and speed. Today, I'm presenting my research proposal titled Transitioning from Black Box to Glass Box, a neurosymbolik framework for auditable and deterministic custom classification. This research addresses a critical vulnerability in how governments apply artificial intelligence to border control. Okay, let us start with the operational reality. The global trade landscape is currently facing what we call an e-commerce tsunami. The cross-border e-commerce market reached a valuation of 21.1 trillion US dollars, projecting a massive growth rate of 27%. The sheer volume of low-value parcels has rendered traditional manual physical inspection mathematically impossible. As highlighted by Rukonova et al., this discrepancy forces custom administration to adopt automated data-driven supervision. However, rushing to adopt standard artificial intelligence creates a severe legal vulnerability. While deep learning offers incredible processing speed, it introduces the black box dilemma. In a commercial setting, if an AI misclassifies a picture of a cat, it is a minor glitch. In a custom context, classifying goods for taxation or security is a statutory process governed by strict laws. Legal scholars such as Canali and Richmond emphasize that technical explainability, like a heat map showing what the AI look at, is not enough. We need legal explainability, which requires a justification based on norms and statutes. Probabilistic AI models cannot provide this. If we use a black box, we cannot defend our decision in a court of law. Let me illustrate this gap with an excellent occupational example. Imagine an X-ray scan of a package contain a knife. A standard convolutional neural network (CNN) looks at the shape and confidently predict knife with 99% accuracy. However, custom law doesn't just care about the shape. The law distinguishes goods based on material and function. Is it a kitchen knife for culinary use, or is it a combat weapon subject to strict security restrictions? The AI lacks this statutory context. Current state-of-the-art models either analyze text or match images, but they fail to resolve this legal ambiguity because they are not constrained by deterministic logic. This is the research gap we must fill. Okay, to bridge this gap, the study asked two primary questions. First, from a design perspective, how can we architect a neurosymbolik framework that integrates probabilistic deep learning with deterministic symbolic logic for custom classification? Second, from an evaluation perspective, to what extent does a proposed human-in-the-loop mechanism improve legal auditability and reduce errors compared to traditional black box models? Correspondingly, our objectives are to design this type intellect artifact and to empirically measure its effectiveness in improving user trust and reducing legal errors. Because our goal is to build a practical artifact to solve an organizational problem, I'm utilizing the design science research methodology, or DSRM, by Beavers et al. However, evaluating an AI system that interacts with human officer is highly complex. Therefore, I'm enriching the standard DSRM with the Echelon DSR approach by Tunanen et al. This means the evaluation is split into two distinct echelons, a technical demonstration to prove the code works and socio-technical evaluation to prove it actually helps human officers make better legal decisions. This brings us to the core of the research, the architecture of the proposed prototype. It consists of three components. Component one, the eyes. We use a pre-trained CNN to handle the visual features extraction, which solves our scalability objective. Component two, the brain. This is a deterministic rule-based engine that maps the visual data to harmonize system aesthetics, solving our additivity objectives. And component three is the most critical, the guardrail. Deep learning models are notoriously overconfident. To solve this, the system uses temperature scaling to calibrate the raw confidence scores. We then apply a classification with rejection rule. If the calibrated confidence drops below a threshold, the system mathematically refuses to guess. It triggers a default mode, automatically escalating the ambiguous case to human officers. Then how will we know this works? We will gauge the effectiveness using hybrid matrix strategy. On the technical side, we will measure the expected calibration error to ensure our rejection thresholds are mathematically sound and a fidelity score to prove the logic engine represents the law accurately. On the user side, we will conduct an experimental simulation. We will measure the error reduction rate by comparing decision made with a pure black box versus our neural symbolic system. Crucially, we will use standardized explainability AI plus scale by Hoffman et al. To measure if custom officers actually trust the system default decision. And as conclusion, this research is not about building a better image classifier. It is about building an auditable governance tool. By transitioning from a black box to glass box framework, we can harness the speed of AI while maintaining the strict deterministic logic required by law. This project provides a pragmatic, legally defensible pathway for custom administration to modernize, ensuring that speed never comes at the expense of legal integrity. Thank you for your time. Thank you, Matt.